Yes, okay. Thank you for introducing me. And I call my speech the Calval activities in Svalbard using in situ continuous monitoring and airborne campaigns. And I have also some contributions from Lennart Nilsen at the University of Tromsø, Rasmus Erlandsson, who is a postdoc at NINA, and Tommaso Julita, who appeared before me here. So next, please. Yes, what we have focused on in this study is the lichen-dominated communities in Svalbard. And actually, they are very rare. I think it's only 1% of the land cover or vegetation, and therefore it's very important to detect and monitor such vegetation up there. And here on the image here is from Flintholmen, and you see the lichens cover on the small ridges or terraces and with some depressions, but there are some other lichens in the depressions. The lichens you see is Flaurocetraria nivalis and Cladonia arbuscula, subspecies metis. And what we actually have got funding for was from SIOS was airborne campaign in 2020 and 2021, two campaigns on Koraholmen and Flintholmen, and Reinsdyrflya in 2021. And actually at the same time, in July 2020, we had a team of researchers headed by Rasmus Erlandsson, who did some NDVI and albedo measurements, as well as carbon flux measurements on the ground on Flintholmen and Koraholmen. And they also accomplished ordinary vegetation plot assessments as well. Next, please. Yeah, this is actually on the right hand. It's part of ICU area, and this is Flintholmen and Koraholmen, the small islands within the fjord system. And on the left part, you see Rasmus Erlandsson, who is conducting albedo measurements on the ground on this lichen tundra. Yes, please, next. And at the same time, the same week, actually, they flew over with a high specs spectrometer. This is from July 2020, and it is the white gray areas that actually have this cover of lichens, and but also in more dark gray, some small greenish, there are also lichens, but the species might differ from the ridges. Next, please. And we haven't done any, actually, we got the data from the Dornier or high specs this week, and the first data, and so far we haven't actually tried to assess what quality this is, but it looks fine. But we have actually assessed some of the NDVI measurements we have done on the ground, and try to upscale them to Sentinel-2 data. And on the right hand, we see the view, the regression or the correlation between NDVI taken with the active sensor green seeker and the NDVI Sentinel or measurements taken from the Sentinel data that was nearest up to the week we were there. And as you see, there is a very nice correlation between the ground-based active NDVI measurement and NDVI extracted from the Sentinel-2 data. And on the left hand, we have actually a view graph that shows that the linear regression shows that the NDVI is overall dependent on the cover of pale lichens on Svalbard. So actually, it's the opposite as the vascular plants. If you have a very high dense mat or grass, you will have a high NDVI. That is not the same with NDVI for lichens. Actually, when you have up to 100% of dense lichen cover, then you have the lowest NDVI measured, and it's about 0.2 or less than that. We have measured down to 0.08 or 0.08 NDVI measured in the middle part of Norway. Next, please. I will report on actually using the airborne campaign later on. So we go to the SIOS. Actually, what Tomas was telling about flux station in Svalbard, and this is actually an integrated part of the so-called automatic system for monitoring vegetation and environmental seasonal changes called Osmoven in Svalbard. And I think you have got information about SIF, or solar-induced or sun-induced chlorophyll fluorescence, before from Juan and from Tomaso. So I can go straight to the next view graph, please. And you see actually what we are here. We try to closing the gap between the satellite imagery and actually ground observation with the flux and the racks we have situated around the Advent Dawn. Next, please. And this is a map over all the racks we have in Advent Dawn. Next, please. And this is actually a view graph showing the onset of growth 2018 and the situation of the satellite Calval sites we have, and the phenocamps as well. Next, please. And here is some picture of the racks, and we have also some wingscape cameras that overlooking the landscape and the flux station. And as Tomaso mentioned, it's actually what the flux station is monitoring is grass-dominated area with Dupontia fishery, called tundra grass in Norwegian, and the Aerophorum scaescheri, which is actually polar white cotton grass. Next, please. And here is the results from the flux station 2019-2020, and you see there is quite a difference with the extracted EVI, NDVI, and SIF measurements from the 2 years, and you can, I think it could be due to that was a very warm summer in 2020 compared to the summer of 2019, and as you see on the NDVI is much higher than the in 2020 than 2019. Also, the start of growing season was also somewhat earlier in 2020 than 2019. Next, please. And here is actually the formula for this Mary's terrestrial chlorophyll index, MTCI, that that Tommaso showed in the former lecture before I started. And this is actually an index developed by Dash and Curran in 2007, and uses the 3 red near wavebands, near infrared wavebands centered at 680, 708.75, and 753. It's close up to the 760, which is the band that is used in this SIF. Next, please. And this is actually taken, I got from Tommaso, and you see the MTCI index, chlorophyll index, and you see that's, and I think it's due to the higher summer temperatures, and also the summer of 2021 is one of the coolest the last decades. And I think also there have been not so nice weather in Svalbard, as we have had this also in northern Norway, and the August was very cool in Tromsø. Here I'm staying. Next, please. And I'm going actually in the next speech, I will go on the ground in the next lecture. But before I turn to the next lecture after a break, I will go back to the Stone Age in imaging spectrometry. And actually, I had two articles on imaging spectrometry in my PhD study, and this was actually taken. This imaging spectrometry data was taken with in an airborne campaign near to the Russian border. This is still Arctic, but it's not the high Arctic. It's more low Arctic or boreal area, and this CASI is a Canadian spectrometer. I think it's not our own anymore, but it was acquired in July 1991. And the overall objective of this study was to assess the applicability of the KC, both spatial but also spectral mode data for the detection of vegetation damage, for studying air pollution impacts on, and for studying pollution impacts on the vegetation in the area. Next, please. And you see, we picked up 8 bands that actually are taken in the visible and the near infrared area, and quite near the max near reflection is about 745 to 758. So it's actually a broader bands here. Next, please. And on the left side, we see image combining the near infrared band with 2 of the other bands, 1 and 2. And actually, as I said, this was close to the Russian border, and in the nickel area there is 2, or on Zapolyarny is 2 copper nickel plants that emit a lot of sulfur dioxide and heavy metals into the environment. And in nickel, this plant is now closed down last year, and in Zapolyarny is still running. And we did did some overflights and campaigns in the Jarfjordfjellet, but also western part of this area, which is highlighted. And in the area which is highlighted with this border is area which is have a high level of pollution and vegetation damage in it. Okay, next, please. And here we see actually Jarfjordfjell A and B. Jarfjordfjell A is better situated, but while the Jarfjordfjell B is very polluted. And actually we had some stress meter or chlorophyll fluorescence measurements in on the birch and bilberry there in A, but in the B section, it's the birch is not living anymore because of the high pollution, and either the bilberry. So we have also compared it with other places further west and in more remote areas. And as you see, there is a number of species in B, which is very high polluted area, is only the half of the number of species there, and also the more significant higher heavy metal contents of nickel in lichens. Next, please. And you see here is the red edge shift, and you see there is actually for the open heat B and Empetrum heat B is dwarf shrub, Empetrum nigrum is in a way skewed to lower band lengths and wavelengths, and And there is also actually in band 2, it's very sensitive to carotenoids, and it's higher there. So in a way, the red edge is skewed to lower wavelengths for the more polluted and damaged vegetation. As you can see, this is representative in a more yellow and gray areas. More or less, the gray areas are quite denuded areas because of the high resolution or high pollution impact. And this is actually the last one, which is only. I have put these articles, this article on the Dropbox, so you can see yourself.